Okay, so let's start. So, welcome everyone to today's session. And this is about the concept of priority map, and we will give its correct name when we are discussing the new topic. Suppose a customer is looking to buy two items, and he went to the market, and there are two options available. Either he can buy a fish or he can buy mangoes. So there are two products that he is looking to buy. One as a fruit, another is as a food. So what he's doing is he has certain. Let me start writing on the screen. So he has a certain priorities that he is looking for. Means he is thinking that I should buy a specific amount of mangoes and a specific amount of uh, fish so that he can be satisfied. So while he's in going to shop, what he's doing is that he's looking at the possible bundles. He's looking at the possible bundles. So you can see it here is that he has seen that either he can buy 6 units of mangoes one uh, and 1 unit of fish. So this is bundle number one. Bundle number one. Similarly, 6 units of mangoes and 2 units of fish. Bundle number two. Bundle number three. Bundle number four. So there are infinite bundles. So you should remember that since you can pick any weight of fish and any number of mangoes, so you can have infinite combinations between two goods. So even though there are infinite combinations, uh, there are infinite combinations. So but I'm showing few. I'm showing few combinations so that you can see. So I have shown like 4 to 8 and 12, 16, 20, 21 bundles. So infinite, uh, in this box there are infinite dots, but I've shown only few so that you can see that he has to pick one of them out of all these possible combinations that he is observing. So as a rational agent, what he wants to do is that this is the bundle that he wants to avoid. This is 0 comma 0. So he wants to go away from it because this means he is getting nothing, and he wants to go, either he wants to get more mango so that he can go away this way up, he can go away in terms of fish so he can get more fish, or go away in terms of both. So his objective is to go as far as away from the zero. So this graph shows that consumer is looking to get a bundle which is as far from zero as possible. So because for him zero means zero utility. So the more away he is, the bigger bundle he will have. Suppose this bundle is 5 comma 5. This bundle is 4 comma 4. So this bundle has 8 items. This bundle has 10 items. So definitely 5 comma 5 utility from 5 comma 5 will be more than utility from 4 comma 4. So this is ordinal utility. So even though we don't have any value how much utility we get, but we actually know that 5 comma 5 is better than 4 comma 4. So it is rankable. So the dots which are away from 0 are better. So we can rank them. So this is the ranking. So this one is better than this one is better than this one. So best, second best, third best, fourth best. So similarly, all the dots could be ranked. So this is the map of what you call it, the customer priority. So let's draw more detail on it. So if we make the axis on it, so you can see that each dot is in a different combination. So if we number them just to give some value, so this is 1 plus 6 is 7, 6 plus 2 8, 6 plus 3 9, 6 plus 4 10, 5 plus 2 is 7, and then 4 plus 3 is 7, 3 plus 4 7, 2 plus 5 7, 7 6 plus 1 7. Similarly, this is 8 8 8 8 8 8. This is not 8, this is 9. And so let me rub it. Okay. So similarly, this is 9 9. So I've drawn these dots in a way. Oh, this is 9 9 9, and 7 plus 2 9. And these are 10 10 10 10 10, and this is 10. So I have assumed that the values of the x's, if we add them, it will give a value to the box, to the bundle. So bigger number means bigger utility. So this way we have given ranking. So 10 is greater than 9, 9 is greater than 8, and 8 is greater than 7 in terms of utility. So this is the way we are ranking. So logic that we are using is bigger bundle is better. So we have given this way we are making. This is the approach that we are already discussing, ordinal approach. Okay, so this is the point that we are clearing it here. So let's see what it is showing us next. So if we join all the dots which have similar numbers, we have these curves. So we call it difference curves. So why these are called indifference curves? Because it is joining all the dots which had same value. So 9, 9, 9, 9, 9, and 9. Then there's 8, 8, 8, 8, 8, 7, 7, 7, 7, 7, 7. So indifference curve is a line, the line which represents the bundles which have same utility value. Okay, so we can it has same utility value. So why we call it indifference curves? Because if you ask a consumer to buy this A bundle or a B bundle, so for him they both are equal. So utility from A is equal to utility from B. So he cannot decide which one is better because they are giving him equal happiness. So he is indifferent. So he cannot decide himself. So we call it indifferent. So he is confused, or he cannot find any difference. That's why the word is called indifference. So since he is indifferent, so we name it indifference curve. So we can label it that this is utility number 10, utility curve of 10, this is utility curve 9, this is utility curve 8, this is utility curve 7. So we have labeled the curves as some with some value. So this is the utility curve. So let me erase the numbers so that we already have the numbers written on the curves. So we don't need to number each dot. So each line is representing the dots which have same utility value. So by the order of ordinal utility, we came to know that Okay, so by the order of utility, so it is uh, so utility from 10 is greater than utility from 9 is greater than utility from 8 is greater than utility from 7. So what does it mean? That the above orbit is a bigger value, so it is better. And one other logic is, so the higher the orbit, more far it is away from the zero. So you can notice that this line has more distance as compared to this line, as compared to this line, as compared to this line. So the more far away the line is, higher the higher the utility that it might give. So customer will prefer the line which is away. So this is the priority map. So in summary, what we are saying is that rather than making infinite dots, we find out that there are orbits, and orbits includes all the dots which have similar value. And rather than showing all the dots, we only show the orbits, and the orbits are showing the same properties as the dots which are within the line, and the customer is trying to maximize the utility. So in real life, because there are infinite dots, so rather than drawing dots, we draw the lines. So it means this is line utility curve 7, this is utility curve 8, and this is utility curve 9, and this is utility curve 10. So for a customer, and this dot, if you compare this with this with this and this, so 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 it means that the let me read. So this is red, and then we'll have a green, then we have a pink, then we have a blue. So red is better than green, and green is better than pink, and pink is better than blue. And what is the logic? So more the indifference IC curve is away from 0, the bigger the bundle it may have, so higher the utility it will give. So higher curve is preferred by the lower curve. So these curves, because the dots are infinite, so there are infinite lines. So I am only showing 4 lines. So there might be a line here for utility 6, utility 5, utility 4, utility 3, utility 2, utility 1, and utility 0. Similarly, 7.5, 8.5, 9.5, 11. So there are infinite lines. Okay, so drawing all of it. So there are infinite lines. So for example, here, so we are only showing 4 lines, and each line has its own value, and all the dots which are on the line have same value. So the value on the of the line is depending upon the common value of all the dots which are existing on that line. So technically it's a orbit, and we as a customer, we are trying to climb or hold on to the highest possible orbit. So higher orbit means higher utility. So as a customer, as a rational agent, the more the higher utility orbit that he get, more happy he will be. So his happiness depends upon the utility curve where he is standing. Okay, so let me clear it. Let's see what comes next. So so what does indifference curve define? So indifference curve is that it is the imaginary set of imaginary curves. They are imaginary because we already know that we cannot measure the utility. That's why they are imaginary. So it's a set of imaginary curves that shows combination of two goods which provide individual with same amount of utility, such that he can choose any combination on the line. So since he is getting same happiness from all the dots on the line, so he is equally happy with any dot that he can get. So that's why we call it indifference curves. So he does not mind which curve he is, which dot he is getting on the line. So it means that if I draw the curve here, let me take some visible color. So if I draw indifference curve here, so this is y-axis and this is an x-axis. So there are two products, x and y, and there is an indifference curve like this. So for a customer, this product, this product, this product. So it's a bundle. In this bundle, y is more than x. In this product, they are almost equal, and this product, x is more than y. So bundle A, B, and C. So for this customer, this is indifference curve because utility from A is equal to utility from B is equal to utility from C. And so he is getting equal happiness. That's why it is called indifference curve. So this is the basis of this definition. So let's forward. So there are four properties that we'll discuss in detail in this chapter, and these few of them are already discussed. But first property is that customer wants to our rational customer wants more and more happiness. Hence, the curve which is furthest from the origin, the 0 point, he is more happy. Okay, so the highest amount of utility. So he wants to climb on the highest curve. This is we already discussed. Second is it will be negatively sloped. And why it is negatively sloped, we will go to it on detail. So it is negatively sloped because to keep the utility constant, when one good is increased, other have to decrease. So it means when he's moving from point B, so let me take another color. So when he's moving from point B to point C, he here X is increasing. So in order to make sure the utility stays fixed, he has to reduce Y. So if he is not reducing Y, it means he is not going here, he is going somewhere here where B is constant. It means he will be on the higher indifference curve which has higher utility. So since the utility must remain constant, so if any product is increasing on the indifference curve, the other one should decrease so that the trade-off makes the utility curve same. Otherwise, if one of them is increasing and other of them is other of the item is not decreasing, it means he is climbing on a higher indifference curve. So we he likes to go to the higher indifference curve, but while defining an indifference curve, if a utility is not changing, it means the utility curve is not changing. So it is negatively sloped when if he is increasing one, he has to decrease the other. So there's a trade-off. Okay. So next is it is inward bended because customer wants the combination which has both goods. That's why it does not touch the excess too. So I will discuss that in detail. Then nature of product defines the shape of indifference curve. Okay, so we'll move on to that point when we are discussing these sides. Okay, so let me clear it up. So there are four properties. The first property is so indifference curves are downward sloping. Okay, so what does it mean? So suppose if he's moving from point A to B, so when he's moving from A to B, uh, suppose the quantity of fish that he's consuming is reduced. So he will be equally happy if you give him some of the mangoes. Okay, so if the quantity of fish is reduced, the quantity of mangoes must be increased to keep the consumer equally happy. So it means that if the utility on the I curve is same, so we already know that utility of A is equal to utility of B, even though the bundles are not same. So if bundle A is the fish in the bundle A is reduced, we should give him some of the mangoes so that he can climb back to the original indifference curve. Otherwise, what will happen if you don't give him the bundle B? He will stay here and he will be on this indifference curve, which has lower value. So utility from I1 is more than utility from I0. So this way we are talking. So it is downward sloping because negative slope or downward sloping because when one is decreasing, other is increasing. So that the utility is constant. CONS constant. And by definition, on this line, utility is not changing. Bundles are changing, but utility is not changing. Okay. So let's see what's next point. So then is that higher indifference curves are preferred than the lower ones. So let's say that there are three indifference curves and there is point C and point A. Okay, and there is point D. So uh, customer prefers every bundle on I2. So we already know that I2 has a utility of I2 is more than utility from I1 and is more than utility from I0. Okay, so he will definitely prefer I2. So it means that C is better than A is better than D. Why? Because he is on the higher curve. So he prefers every bundle on I1 as compared to bundle on I0. So C is better than A and A is better than D. So this means, so what is the logic? Because the the distance from 0 to D is smaller and 0 to A is bigger and 0 to C is biggest. Okay, so more distance, more happiness. So it means higher indifference curves are preferred to the lower ones because they are covering more distance. So he likes to climb on the higher indifference curve. Okay, so this is the why they are. This is the reason is that it has a property that higher are better than the lower ones. So this is the arrow that's showing that he wants to go away from 0 point. Then the property is that indifference curves do not cross each other. Suppose we draw two indifference curves. They are crossing each other. So logically, we from this curve we notice that utility from B is equal to utility from A because they are on the blue line, and because of the red line, utility from C is equal to utility from A because both are on red line. So this means that utility from B should be equal to utility from A, but it is not true. Why? Because utility from B is greater than utility from C. Why? Because B is on the above line. Okay, so the same thing is discussed here. So consumer should prefer B to C because B has more goods and B is on the above line, and B has covered more distance. So distance from 0 to B is more than distance from 0 to C. So he should prefer these 2 points. Should prefer B to C. But yet consumer is indifference between B and C because C is equal to A and A is equal to B. So logically C should be equal to B. He likes C as much as A and he likes C. So continuity theorem says that C should be equal to B. But logically both properties cannot stay at same time. So first property is that utility. So first property is that utility from B is greater than utility from C. Second property is utility from B is equal to utility from C. Okay, so both are not equal, both cannot exist at same time. So since this property is coming from mathematics, so it will hold always, it cannot fail. So this is continuity, uh, it's this will hold. So it means if we need to make sure this holds, then this property will not hold. And if you want to make sure this property does not hold, you need to make sure that indifference curves are parallel rather than they are crossing. So definitely it will not cross each other because they are, if they cross, they will make break the rule that we are discussing here. Okay, so this is the why indifference curve do not cross each other. Okay, so let me clear it up and let's go to the next point. So now last point was that why they are inward bended, why they are bowed inward. So why these curves are bending towards the center, towards the origin rather than they are straight line or bending outward. So let's discuss. So let's discuss. We have two bundles, bundle A, and let's write their properties. So in bundle A, mangoes are more than fish. Okay, and in bundle B, fish are more than mangoes. So we already discussed that uh, when we have one thing in abundant, its utility falls. We have discussed that in diminishing marginal utility. So when we increase M, its utility falls. So we have discussed that in the previous class. So I will draw it here. So let's talk about mangoes and utility from mangoes. So we discussed that when we eat more mangoes, its utility false. Similarly, there is fish and utility from fish. So the more fish we eat, its utility will fall. So it is talking about same thing. So if you take a center point here, where uh, if you take a center point here, what will happen? If you start increasing mangoes, okay, so you notice that it is first of all increasing, then bending, like this blue line. Similarly, when you're looking towards a fish, it is first of all increasing, then bending. So it is talking about same thing. So customer is willing to give up more mangoes for fish if he has fewer fish. So in point A, he has less fish. So the thing which is in lower quantity will give him will give him more happiness. So he will try to give up the mangoes because he have an abundant, and he will try to get fish. So that's why the number is bigger here. Then when he has more fish, he will not he has more mangoes. In the point B, he has less mangoes. He is willing to give more fish. So in short, let me clear it up and let's summarize it. So why they are inward bent? Because the center point is a balanced bundle which have equal quantity of both products. M is equal to F in this balanced bundle. So if you move towards up where you have more mangoes, so when you increase mangoes, what will happen? The happiness from mangoes will fall. So if you move this way, the utility from mangoes will fall. Okay, because of the law of diminishing marginal utility. So, and if you go this way, the utility from fish will fall because of law of diminishing marginal utility. So since the happiness from mangoes is falling, what is happening? The need for F will be increasing because you are when you're moving here, you are reducing the fish. So you would like to get more fish because
We already discussed, what we discussed is the more it means less utility and less means more utility. Similarly, here the need for mangoes will increase. So this thing is being discussed here. So let me move the slide. Hence, people want to have a balanced bundle at point C, where they both are equal. So let me conclude this point. So customer wants to go to the highest indifference curve, but uh, he also wants the balanced bundle. That's why the distance of the highest indifference curve in the balanced bundle is smaller than the distance between 0 and B and 0 and A. So what does it mean? So let me write it as 0 C distance is smaller than 0 B distance, and it is smaller than 0 A. So let me ask one small question here. So what does this distance mean? So here distance means cost. So he have to pay for that bundle if you want to go to the higher bundle. So since he wants to go to the highest indifference curve, but he also wants to go to the balanced bundle, so he has designed, or psychologically the indifference curves are designed in a way that the balanced bundle has the smallest distance, so that it has the smallest possible cost. So customer, rather than try to go to A or B, which will cost him more, even though the C utility is equal to A utility is equal to B utility, but the distances are not equal. It means cost from C is smaller than cost from B is smaller than cost from A. So he tries to go to the lowest cost. So this is cost minimization, and since the utility is same and it is highest possible curve, so this is utility maximization. So what we are learning here is that the indifference curves are designed in a way that he tries to maximize the utility by minimizing the cost too. Otherwise, he could go to point A, but it will cost him more. So logically, let me clear it up and answer one more question here. So if he could afford to go to point A, so let's draw an arrow here. So let's see, let's suppose that he can afford to cover this much distance. So he have this much resources. Then why don't he move to another indifference curve with point D where this distance is same? So here, here we can see that OA is equal to OA is equal to uh, OD. So since O and OD are equal, but in cost, but utility from OA is less than utility from OD. So if he can afford A bundle, definitely he could have gone to D, where D has higher utility. So this means that, so customer, what customer does is he tries to hold on to the nearest point of the highest bundle, or nearest point of the highest indifference curve, so that he can get highest utility, rather than he goes to the furthest point of the higher indifference curve, which will cost him more, rather than he could have gone to the higher indifference curve at the lowest point. So what is it doing is, so logically there is utility maximization and cost minimization going on together. So logically what he's doing is, so he knows that in order to maximize utility, he has to get uh, highest happiness with lowest cost. So that otherwise he will not get the highest utility. That's why they are curved inward. So psychologically it is drawn like this. So what does we mean by term indifferent. So now we are summarizing it. So let me. So what does the term indifference means? Indifferent means that uh, so utility from A is equal to utility from B. So he cannot decide with available information. He cannot decide with available information that he what bundle he should get, A or B, because the it looks like they it have equal distance. Okay, so what does indifference curve represent? It represents the set of bundles which have happiness, equal happiness bundles. So what are its properties? We have discussed uh, its properties. So why when it can be a straight line? So first of all, let me tell you why it is bended. It is also bended because product fish and mangoes are not perfect substitutes. So since fish and mangoes are not substitutes, that's why he tries to get both. So it will be straight line when they are perfect substitutes. So it is shown in the next slide. Let me get it there. So there are four types of goods. There are substitute goods where two products can be used as an alternative, like pen and black pen. The complement goods where two products are used together, like car and fuel. Normal goods are goods which we buy more when we have higher income. So when we get rich, we the things we buy more are normal goods, and there are inferior goods, the goods which we buy less when we have more income. So these are related to our income. These two are related to our use. So if we use them together, they are complements. If they are used as an alternative, they are substitutes. If income increases then demand, then it is normal good. If income decreases it, then it is inferior good. So like second-hand items, when we are rich, we try to buy branded items. So second-hand items are inferior and branded items are normal goods. So so let's see what we have left. Okay, so there can be three types of indifference curves. So first is we already discussed. What was that? When they are not substitute or not complement. This is this type we have already discussed. But if the products are perfect substitutes, it will be a straight line. But and if they are complements, it will be a L-shaped line. So when they're complements, we tend to buy the balance bundle only. So for example, it's a left shoe and right shoe. We like to buy one and one so that it's one set, or two and two rather than two of left shoe and one of right shoe. So that's why for complements it's an L shape. For the case where they are not substitutes or not complements, like the example we discussed, mangoes and fish, it will be the standard curve. And if they are substitutes, means they are can be used alternatively, it will be a straight line. So this is the three types. We will do an activity on it later on. Then there is let me do the screen share here. So what is discussing there is the nature of indifference curves, how they shift. So climbing on the indifference curve, if it only occurs when person has more income. So if the customer's income increase, it means he can, so increase in income means cover more distance. So it means he can go to the higher indifference curve. So suppose these are three indifference curves. So if the both products are normal, so increase in income means he will first of all go to A, then this A and this A. So he will climb it normally. So he will. So if the income increase, he will go to the higher indifference curve, which is parallel to the previous one. So let's say that if he has income I1, he's here. When he's income I2, he's here. When he's income I3, he's here. So since the both products are normal, so he is climbing on to the parallel indifference curves. That's very important to remember. Okay. So let me clear it up. So what will happen if one of them is inferior? Suppose Y product is inferior. So what will happen when he is increasing his income, he is going away from B. So you can see the more distance is here and less distance here. So when Y product is inferior, the indifference curve will not be parallel. It will be aware from point B. So he will go, it will move towards point A. So let me draw the case here. Suppose he is on this point, then he goes here, here, so on. So what will happen when his income is increasing, rather than going in a 45-degree line, he will try to bend towards the normal good rather than inferior good. That's why indifference curve will go away from this inferior good case. So that's why they are shown like this. Hopefully you understood. And in our activity, what we'll do is we will do a calculation and then we'll learn how to draw this diagram. So in the last summary, we have a set of, we have first point, we have set of goods which are lying on the axis. Okay, and these set follow orbits which are known as indifference curve. Okay, and since there are infinite dots, so we don't we follow orbits as compared to sets, because there are infinite sets, so we, rather than follow them, we follow the orbits. And we want to go away, so rational agent likes to go away. So this is our priority map. But the problem is we have a budget line. So let's start it here. So V is let me get point. So V is, there is a budget constraint. So it is stopping us to go away. So what will happen? So we can only go to the blue line, and the shaded region is the affordable region, and anything outside is unaffordable. So customer will try to do is, he can go to the blue line, and blue line is his affordability, which we already discussed in the previous class. So affordability, and since he will look on these blue dots where the highest indifference curve is crossing. So this is this point. So that's why indifference curve are bent inward, because he only have to touch it once so that it is the highest possible. So what customer will do, he will first of all look at the budget affordability, and he will look on this budget line which indifference curve is touching once. So it means he can go on this point rather than this point, even though it has same cost, but this has higher utility rather than this point, even though this is costing same as this one, but it has lower utility because it's on the lower indifference curve. Okay, so let's see. So it means customer will try to stay on the indifference curve which is touching only once. So this is the discussion that we did it today, that our budget line is the customer resource and it is pushing us down because the resources are scarce. And indifference curve is the map of needs, and we try to go to higher point. So the optimal decision depends upon both curves. So we try to go on the highest on the budget line so that we spend all of the resources, and we try to select the indifference curve which is touches the budget line. So this way we have the highest possible budget. So we maximize utility by using all budget. So this was the section for today. Hopefully you understood the discussion. So that in the next session we'll talk about the logic of how the indifference curves and budget line are drawn together for the consumer equilibrium.